Hello guys, welcome back, and for these videos we're gonna start for chapter 6, which is called circular functions. So for this one, it's more like the revision things, and then we talk about more, in depth slowly. So first, why is circular functions? And before we think anything about it, we have to familiar with like degrees and radians. So which means how to convert each other. Essentially, one pi, okay, just 1 pi, just equal to 180 degrees. And this is the converting stuff. And again, we make sure if the angle is formed anti-clockwise, we think it's positive. Then if it's clockwise, we think it's negative, okay? And to be honest for you guys, in once you enter the VCE level or like year 12, the most frequently used angle measure is in radian. Okay, you can convert these two models, but personally I suggest you model stay with the radian. And if the question is specially asked to degree, then you convert it back. Okay? Otherwise, most of the time stay in radian. Okay, and let's keep going. So 30 degrees convert to radian because 180 is pi, so 30 is 1 over 6 out of 180 degrees, which means this one is pi over 6. Okay. And this one again convert to each other, pretty easy and straightforward. So this one 6b define circular functions sine, cos, tangent. Before we call them as circular functions, we actually call them as trigonometry, right? And in I think in year 9 or year 10 textbooks, we have the right angle triangle. Then there's the theta, we make A, B, and C. So our sine theta is A over C, which is opposite over hypotenuse. And our cos theta is B over C, which is adjacent over hypotenuse. And tangent theta, which is opposite over adjacent, right? So again, based on this definition, we only can define our maximum theta value is going to be less than 180. Makes sense? Less than a pi. But if we use CAS or use any other, calculators, you plug like in sine 300, they give us some numbers. You even type in cos 10,000, they give us numbers. So which means only in the triangle definitions, there's a problem for us, right? So we need to extend our definitions. That's why for now we call them circular functions instead of trigonometry. Okay, let's see how it be determined. Okay, first one, we draw a unit circle. Unit circle means radius is 1. Okay, and there's a moving point P over here. Randomly dot, just make it over here. And then the P, of course, got x coordinate and y coordinate, which here is x and here is our y. Okay, and then our cos x, adjacent over hypotenuse, which is just like, cos theta, my bad. Theta is the angle formed by the point connection with origin and the positive x-axis. So cos theta is just like x over 1, which is x. And sine theta, same thing, y over 1. Okay, opposite over hypotenuse is just 1. So now you realize my p coordinates no longer need to use x and y to express or represent. I can directly use cos and sine. Make sense? So with this definition, I realize if my p just rotate for the whole circle, it gives us 360. If my p continue doing the same thing, then it will gives me like 720, right? So I can keep rotating. So technically my p can be the infinity to everywhere. And if I'm going to clockwise, okay, I'm going to such this direction clockwise, and my p can be negative infinity. That's our extended as the range, or let's say extend our domain. or like the boundary for P. Okay, that's why we call it circular function, because we define in the circle, in the circle, right? So let's go back a little bit over here. In here, in this angle, it means zero. Sorry, in this point, it means 0, 1, which means 90 degrees for theta, and our cos theta is just 0, and my sine theta just equal to 1. And over here is negative 1, 0, so my cos 180 is negative 1, or I should say cos pi is negative 1, right? And my sine just like 0. And here it's the same thing. So for this, for the initial point, I just want you guys to make sure you know how to do A to H. Okay, sine pi on 3. I just draw the circle maybe over here. Just give me a sec. I just draw the circle. Okay, over here. So this is my moving point. Okay, over here. So it's 0, negative 1, this 1, this is 1, this is negative 1. Again, it's going to be negative 1, right? And sine negative 3 pi on 2 is going to be in here. So it will be positive 1. And again, cos 5 pi on 2, you take the whole circle, okay? And then back to here, which is going to be give you 0. Okay, you apply the rest of the same strategy over the circle. And this thing is start tricky because they ask us about tangent, but tangent essentially just sine over cos, right? So again, you can convert to sine over cos to get the ideas. And example 4 is not important because they just ask you to cast to help you to do it. And now we look at exact value for circular functions, which means, oh sorry, I haven't got that yet, which means some special angles 30, 60, and 45. Okay, personally, I provide you guys two methods to help you guys familiar with this one. So 0, pi on 6, pi on 4, pi on 3, and pi. Okay, so which it's gonna be, sorry, pi on 2, sine, cos, tangent. So it's gonna be 0, half, square root 2 over 2, square root 3 over 2, just 1. And the cos just reverse, tangent just up, divide by bottom, sorry, divide by middle, then gives this. Okay, so this one not exist. And for the sine things, you can always convert in this special case, which means half square root of 0, half square root of 1, and half square root of 4. So for the bottom, there are always 2 on the bottom, and for the top, it's square root of 0 to square root 4. This is one way to remember, and the cos just write reversely. And another way to remember is special angle triangles, which means over here, 30, and it just gave me 1, 2, square root 3, and 45. Okay, just square 2, 1, 1. Okay, just like this to help you to get the idea. Okay, and I just keep going for this one, 260. This is really important. Okay, which means our ASTC there how to define, because P in the first quadrant, both x and y value are positive, so sine cos positive, which means tangent positive. And we move to the S quadrant 2, y value is positive, which means only sine positive. That's why we write S. And we move to here, quadrant 3. So it means like sine cos both negative, but my tangent is positive. And we move back to the last quadrant, quadrant 4, which x value is positive. So which means only cos is positive. So for this one, you can write ASTC, to help you to remember, or add sugar to coffee, or all station to Campbell, or coffee, or whatever. So just or all science teacher crazy. So just help you to remember this. Okay. So the sign of the circular functions ASTC over here. And then for negative angles, it actually essentially means we convert it in the fourth quadrant. So it's same as our C. Okay. So example 5 and 6, you guys need to familiar with and ready for the converting things. Okay, from the basic one, memories, and to our new one like this to convert it. So question 3, you guys must be practice a lot and make sure you can short the values without hesitation. For example, sine 3 pi on 4 is just the square root 2 over 2, and sine 5 pi on 6 is like half. Okay, you need that speed to help you to get the marks and save your time during the final year exam. Okay, so for next one, 6C, we're gonna talk about more in the next videos. Hopefully my videos helpful and make sure every day practice a little bit. Okay, see you guys for the next videos. Bye bye.